In this video, we'll do the analysis on the stenosed vessel. So in part 1 of this video, we'll draw the geometry and then take it to COMSOL and set up the problem. And we'll do the post-processing in the part 2. So in SolidWorks, we start a new file. And because the geometry, the diameter is varying along the length for the stenosis, so we do not use the extrude. We use the revolve feature to build the geometry. And we want our circle to be on the ZX plane. So we'll build our geometry on the front plane, say XY plane, and revolve it around the Y-axis. So first, let's change the units to millimeters. Then make a sketch on the front plane, taking the corner rectangle and placing the corner on the origin at SolidWorks. So if you set the origin at SolidWorks, then when you take this to COMSOL, the origin will be mapped nicely, so that making cut lines and everything on the COMSOL will be easier. So this is the same as what we did in the class, so this is 100 millimeters. And this is 2.5. And the stenosis at midway along the length. So we take the center point arc tool, and using the midpoint as the center, and this is one endpoint, this is the other endpoint, and we specify the radius of the arc as 1.25. Then to remove this portion, select the trim entities here, and we select the power trim, press down on the left button and drag across this line. So this line is removed. And then we smooth out these 2 points, the edges, using the fillet. So we go here, take this one, and we enter 0.75 here as the fillet radius. And then we click on this one, one. So these are the previews, they're okay, so we accept this. So just to add the dimension for the circle, this was 1.25. So this is our geometry, and this will be revolved around this axis here. It will make a 360-degree rotation around this, so we draw the axis line here, using the center line from here. Take the center line and take alignment from here. This is just a reference line, it is not part of the drawing. So we close this sketch, and with the sketch selected like this, selected here, we take the revolve tool. And this is the preview, it looks okay, so we accept this. So this is the stenosed vessel. And to live link it to COMSOL, we have to turn on this live link feature. So we take tools, add ins, and use this, and turn on the checkboxes, keep the checkbox on. So this is okay. Next, we switch to COMSOL, and we take this one, model wizard, because we made a 3D geometry, so it's 3D dimension. And from here, fluid flow, single phase flow, laminar flow, click the add button, and it appears here. and these are the dependent variables it's solving for: the pressure and the three components of the velocity vector u, v, w along x, y and z directions. So we click the study and we do a steady state or stationary study. This is not time dependent or unsteady. Select state stationary and then done. To bring the geometry from SolidWorks, we click on this one, live link, this one, and synchronize. So the geometry is here, and we see that in the ZX plane the circle is there, and the length is along the y direction, y-axis, along the y-axis. Now we enter the fluid properties. Just before that, in the laminar flow node, if we click, this shows the equation. So we are solving the Navier-Stokes equation, the three equations, and this one continuity equation. So four equations for the four unknowns, three velocity components and pressure. And this is an incompressible flow with no turbulence. So in the fluid properties, we input this density and viscosity. So this is 4 times 10 to the power minus 3. So this is 4a minus 3. Then initially everything is considered as the wall, all the outer surfaces. And the domain means volume and boundary means surfaces. So we add one inlet and one outlet by right clicking on the laminar flow. So as inlet, we specify this face. So this is boundary or surface selection manual. We select this face, and for the boundary condition, there are different options available. We select pressure for our problem, and we specify the value as 5000 pascals. And we want this one to be normal flow for the inlet only. And for the outlet, select the opposite face, so this top face here. We rotate the geometry, select this, and this is the button for the default 3D view. These are x, y, y, z, x views, and we keep the boundary condition as pressure, and we enter the number 4500 here, and we do not check the normal flow, keep it unchecked. Then we build the mesh, so we click on here, and for this fluid flow problem, since this is a change in geometry, change in diameter, so we do not take the normal element size, we change it to coarser or extra coarse or something. So let's do coarser. We click build all. So in the window below the graphics window, the message appears as it is working to build the elements. You see that this coarser element setting gave us some 56,000 elements. So approximately this number of equations will be solved when it solves the equation. And if we zoom in by pressing down the wheel and moving the mouse, we see the elements. These are all tetrahedral elements. And this intersection of the elements, like this point, this point, this point, at these points the variables are solved, the velocity and pressure. So next step, we click on the study here, and then we click compute, and it will solve the equations to get us the values for the pressure and velocity. So when it is solved, we know the pressure and velocity at each of these points, and then we use different post-processing techniques to get our desired results or show it in our desired format. So as it is solving, this convergence plot kind of gives us an idea if the solution is converging or not. So it will take some time to converge, so we can just conclude our part 1 of the video. It is done and the results are given. We'll come back to the next part.